Welcome to Math 1314. This is section 3.1 on quadratic functions. Now, quadratic functions can come to us in two different formats. One format looks like ax squared plus bx plus c. Now, their variable here is x. It doesn't always have to be an x. It could be a different letter. But it's in a format where the variable is squared and possibly the variable itself. It has coefficients of a, b, and c. The only requirement is the lead coefficient a is never 0. Now it may also look like a times something squared plus or minus something on the end. So the important part here is our variable is squared. The shape of this is a parabola. It's a U-shaped object that either looks up, see this one looks up, and this one looks downward. Now it looks up or down, so let's just make note of that. So you have that. So this one looks up, this one looks down. It's going to look downward whenever the lead coefficient a is negative, and it's going to look up whenever the lead coefficient is positive. Now we're interested in several different things on these parabolas. The lowest point here, when a is bigger than 0, this lowest point is called the vertex. And when it looks up like this, the vertex is the minimum. It's the lowest part of the graph. If it's flipped over where a is negative, then our vertex is now the highest point on the graph. So we're interested in the vertex because it's either the maximum or the minimum. If you look at this U-shaped object, it's symmetrical, and it's symmetrical about a line that goes through the vertex. And that line is called the axis of symmetry. And it's just x equals a number, and that number is the first coordinate of the vertex. Now we're also interested in y-intercepts, and we're going to find where it crosses the y-axis by setting x equal to 0. And we're also interested in if and where it crosses on the x-axis. Now the domain for all the quadratic functions is the set of all real numbers. You can put in any number that you like. Now the range as to what comes out depends on if the parabola looks up, and if it looks up, then it's going to go from the minimum up forever on the range. And if it's flipped over, then the range would be minus infinity down here forever up to the highest part, which is the maximum. Alright, so if we look here at question 1. Question 1, we have g of x is minus 3, x minus 1 squared plus 12. Alright, so the first thing I notice is the lead coefficient is a minus 3. It's less than 0. So our parabola is flipped over, which means the vertex is going to be a maximum. This kind is easy to recognize a shift. Alright, this plus 12 on the end is a shift upward. We already saw the minus 3 flipped it over. The x minus 1 part is a left or right. And to figure out which way, set it equal to 0. And so I get x equals 1. And so we go to the right by 1 and up by 12, making the vertex at 112. The axis of symmetry is just this vertical line, and it's x equals 1, y 1. Well, because that's the first coordinate of the vertex. The domain is all real numbers. The range, well, the highest is 12, and it goes down forever, so minus infinity to 12. Now the x and y intercepts, let's see, there's a question about does it open up or down. Ours is down. Vertex we already identified. Alright, what about the x-intercepts? Well, for the x-intercepts you set y equals 0. Now I notice that this part is negative, so I'm going to move all of it, the whole piece, over to the left, making it positive. I'm going to divide both sides by 3. Let's see, 12 divided by 3 is 4. These 3's cancel. And now we can use the square root property because I have something squared equals a number. So x minus 1 is plus or minus 2. 1 plus 2 is 3, and 1 minus 2 is minus 1. And so the points are then 3, 0, and minus 1, 0. So if you go back and look at the graph, you'll see we plotted those. And to look for the y-intercepts, well, you just set x equals 0 and calculate y. 0 minus 1 is a negative 1. Negative 1 squared is 1. 1 times a minus 3 is minus 3. Minus 3 plus 12, and we get 9. So the y-intercept was at 0, 9. Let's see, we already made a sketch. Axis of symmetry was x equals the first part of the vertex. We did have a maximum. And the highest point, or the maximum output, was 12. That's its maximum value. And we already noted about the question about the domain and the range. Alright, let's look here at question 2. Question 2, I've got 3 times x plus 3 squared minus 3. Alright, lead coefficient is positive, so it looks upward, meaning that the vertex is now a minimum. The minus 3 on the end goes down by 3. The inside part is a shift left or right. X plus 3 is 0, so x is minus 3, so we go left. Alright, so minus 3 left and down by 3, making our vertex at minus 3, minus 3. It's a minimum. Axis of symmetry is the vertical line through the vertex. So that's x equals minus 3. The domain is going to be everything, again for all quadratics. And the range, well, the lowest it ever gets was minus 3, and it goes up forever. So the only real question is about these x and y intercepts. So let's go look at that. Alright, so here looking at the x-intercepts, I set y to 0. Now, looking at what we have, last time this whole piece was minus and I moved it. Here the minus is with this 3, and so I'm going to move it to make it positive. And then I'm going to get rid of the 3 in the front. So 3 over 3 is 1. And I've got x plus 3 squared is 1. So x plus 3 is plus or minus the square root of 1, or minus 3 plus or minus 1. And so you get that the x values are minus 2 and minus 4. But they want more than that. They want the points. See, they enter your answer as an ordered pair. That's why they want it written in that format. The y-intercept, well, that's the easy one. We just set x to 0 and calculate. 0 plus 3 is 3. 3 squared is 9. 3 times 9 is 27 minus 3, and we get 0, 24. So again, they want the whole ordered pair, the x and the y. We already made a sketch. Alright, axis of symmetry was x equals minus 3. It was a minimum. The minimum value, or the output, was minus 3. Domain, we talked about that. Alright, let's look here at question 3. We've got 17/4 x minus 4 squared. Alright, well, the 17/4 is positive, so the parabola looks up. The vertex is a minimum. There's nothing on the end, so there's no up and down. There's just this shift left or right. X minus 4 is 0, so I get x is 4, so it goes to the right by 4. So this is at 4, 0. Axis of symmetry is the line right down the middle. Okay, that's good. The low point is 0 on up forever. X-intercept, well, it's the vertex. We don't have to look for the x-intercept. It's just the location of the vertex. We'll just need to figure out the y-intercept. Domain and range, we talked about that. Yes, it does open upward. Alright, no need to do. So the y-intercept, set x to 0. 0 minus 4 is minus 4 squared, which is 16, and then 4 goes into 16 4 times, and 17 times 4 is 68. Alright, we already did all of that. Minimum was at the origin. Okay. Now, question 4 presents us with a bit of a challenge. We have h of x is x squared plus 4x plus 3. Well, the lead coefficient is a 1. Right? It's nothing there, so it's understood to be a 1. It's positive, so the parabola does look up. And the vertex is a minimum. But the problem is there's no easy way to see where did this thing get shifted. We have two ways to figure out the vertex. One, there's something called the vertex formula. And it's minus 1 times b over 2 times a. And then it's your function at that same number. So in our case, a is 1, b is 4, c is 3. And so I get minus 1 times 4 over 2 times 1. Well, that's minus 4 over 2, which is minus 2. So we need minus 2 and h of minus 2. Well, what is h of minus 2? You simply plug minus 2 into h. Minus 2 squared is 4. 4 minus 8 plus 3, and we get minus 1. So I now know where the vertex is actually located. That's one method. The other method is by completing the square. So let's go through this slowly. Here we have h of x. Remember, on completing the square, we needed b. Here's b. So b is 4. We took b, divided it by 2. 4 over 2 is 2. And I need to save that number for factoring. We then took that number and we squared it. 2 squared is 4. And I'm saving that for adding. Now, when we were solving equations, I was able to add 4 to both sides. Here I don't have two sides. So I do something that looks kind of stupid when you first see it, and that is I'm going to add the 4 in and I'm going to subtract it right back out, plus the 3 that's still on the end. Now that seems silly because you say, well, that doesn't change anything. Well, I don't want it to. The trick here is, how do I group it? So I'm going to group together the first 3 and I'm going to group together the last 2. And so I get minus 4 plus 3, which is minus 1. And then I'm going to factor the first 3 using my factoring number. And I get x plus 2 squared minus 1. And this is our h of x, which is exactly what we got from the vertex using the vertex formula. And this is what they're calling vertex form, simply because we can read off the vertex very easily. Alright, so now we know what that is. The x-intercepts, well, I set y to 0. In this case, it is factorable. 3 times 1 is 3. The middle is 3. The outside is 1. That does give me the 4 in the middle. And then I set each piece equal to 0 to give me these numbers. I could also get it using the vertex form and using the square root property to get them. To get the y-intercept, well, that's pretty easy in this format because when x is 0, everything goes away and I get 3. Alright, we made our rough sketch already. Axis of symmetry, how did I get that number? Well, where was the vertex? Remember, the vertex was located at minus 2, 1, and the axis is simply the first coordinate of the vertex. It was a minimum, and the minimum value was minus 1. Let's see, where's my minus 1? Minus 1, yep. X squared, x plus 2 squared minus 1. Alright, so come back to right there. My vertex was at minus 2, minus 1. And so the axis was again the first part. The minimum value is minus 1, the second part of the vertex. Domain and range, we got all that. And that concludes our venture into quadratic functions.